All right, folks, last circle section for us. And in this section, we're going to deal with some segment lengths that interact with circles. First one's going to be the segments of chords theorem. And this is the easiest of the three we're going to do. And in other words, we can be given three lengths and find the fourth. And here's our little equation here with two chords intersecting inside of a circle. So basically, they're saying EA times EB. So you can take this segment here times this segment will equal this segment of the second chord times this segment of the second chord. Just plug them in and do the math. So that's chords. The next one's going to deal with secants. In fact, quick review for you. If you remember, a secant is a line that goes through a circle, touches two places. And a tangent is a line or segment that comes along and touches it at one point on the outside. So just a review so as you see the terminology, you know what to do with them. So let's do an example of this first one, though, so that you see how that works. This is where you have two chords intersecting inside of a circle. So here's an example. I'll find you one. Here we go. So again, we have the product of these two, multiply those together, equal to the product of these two. So it's 3 times x equals 4 times 6. So 3x equals 24, x equals 8. Find you one more of those. Try to do these in groups here. Here's one down here, number 8. So again, this product, so that's going to be 18 times x equals this product, 9 times 16. So I have 18x equals, 144. And now I can divide 18 and 18. Is that going to be like 6? No. 7? 8? Oh, 8. Yeah, x equals 8. A little slow here. Okay. So that one's pretty easy to work with, I think. So let's go to the second one of the three here is going to be on secants. You have two secants. So let me show it to you again. Here's how it works. Here's one full secant and here's another secant as well. Okay. So what we do is we multiply this piece of this lower secant times its full length. So see they have, and then on the other one, same thing. This little piece times its full length. So let's go find an example of that right here. So again, the outside piece, this little piece here, times the sum of that length will equal this outside piece times the sum of that full length. So here's how it looks. Again, the 4, which is the outside, times the sum, so it's 4 plus 5, that's the upper secant, equals the 3 on the outside times the x plus the 3, the sum of the two. That's pretty much it. So it's 4 times 9 equals 3x plus, 9? 36 equals 3x plus 9. Subtract 9, so 27 equals 3x. X equals 9. Okay, I'll find you one more of those with the secants. I'll try this one here, I guess. See how it works? Again, you got the two secants. I want the outside piece times the sum. The outside piece times the sum. Sum means add. All right, so 6 times 9 plus 6, that's the top secant, equals 5 times the sum, x plus 5. All right, 9 times plus 6 is 15. 15 times 6 is 90, I think, down here. 5x plus 25. I subtract 25. 5x equals 65. Divide by 5. X is 13. So far, these are coming out nice. A lot of these kind of problems come out with decimals a lot of times. So that's two of those with the secants. And the last one we got for you, gotta find it here. Where are you? Oh, here we go. We're doing a tangent and a secant. So this is what they got. You have a tangent line. And with that, you're going to just square that value. Whatever it is, you square it. That's going to be then equal to this small outside piece times the full length. Okay, so that's a little different than all the other ones. So let's go find an example of that. Well, here's one right here. So I have the equation right above. Here's my tangent right here, and that's the 16. That's when I square. In fact, here's the equation right here. So it's going to be 16 squared equals the small piece on the outside, okay, that's the x, times the full length, x plus 8. So 16 squared is 256 equals x squared plus 8x. And then, this is a bad example for us because we have to do reverse FOIL. We have not talked about this during this time. So this particular example is one you won't have for your homework. I'll show you an easier one in just a second. Okay. All right, so let's find an example for you. Here we go. This is an easy one. Number 5. Again, look, you have your tangent here, and then you have your secant here. So I have to square the tangent, and then I got to multiply this outside piece times the sum. Okay? This will come out a little nicer. So I take 7 squared, that's the tangent, equals the small piece 5 times the sum, x plus 5. Or you add them up. So it's 49 equals 5x plus 25. Subtract 25, I have 24 equals 5x. Yeah, you're going to divide. You have a decimal. A lot of these are going to come out to be decimals, folks. It's 4 point something, 4.8. I don't know. Yeah, 4.8, I think. Or roughly that. Okay? I'll find one more for you that's going to be reasonable. Hang on, let me just find one. They're not always easy to find. La-di-da. Yeah, here's one. Number 10. Again, here's your tangent and your secant. I'm going to square the tangent. It's going to be equal to the outside piece times the sum of the two pieces. So 24 squared equals 12 times x plus 12. So this is 576, I think. 12x plus 144. Subtract 144. That's 432. 432 equals 12x. Divide by 12. I have no idea what that is. Don't have a calculator with me, but you can find that on your own. All right. I'll try another example or two of each if you want to. Otherwise, you can just go do the problems. Here's something with the chords that intersect. Again, here's one chord. These two, the product is going to equal to those two. So it's going to be 9 times x minus 3 equals 10 times 18. 9x minus 27 equals 180. I add 27 to both sides, so 9x equals what? 207. Divide by 9, x equals 23. Okay. Let me find you one with the two secants. I'll try number 6, I guess. Again, for the two secants on number 6, it's the outside times the sum, and the outside equal to the outside times the sum. So 6 times 10 plus 6 equals 8 times x plus 8. So this is going to be 96 over here. 96 equals 8x plus 64. Subtract 64. 32 equals 8x. Divide by 8. X equals 4. That turned out pretty nice. And I guess one more of the tangent for you, if I can find one here that's nice. And I don't see one that's nice. But I've given you several examples so you can do the homework. All right, folks, good luck.